Okay, so I'm going to start. I'm going on to for our next part of 10.8, which is where we're talking about where the events are dependent. And we can put that title up in a minute. Bear with me for a minute right here. So it's going to have a different formula. And here comes the title first. Let's start with the title. As a matter of fact, let me make sure that I've got all of my paper before I start. I want all of my paper. Here we go. Here we go. There we go. Okay, so now we're talking about now the probability of dependent events. Probability of dependent events. Dependent events. Okay, now here's the example. Let's say you've got this is going to be example number one. And first, let me show you the formula. So the formula for this is the probability of A and B, A and B, is equal to the probability of A, that's going to be the first event, times the probability of B given that A has occurred. Has occurred. Okay, so here's the problem. Two cards, the experiment that we're talking about, two cards are drawn from a deck. From a deck. Now here's the key over here. Without replacement, meaning after you take the first card, you don't replace it. You don't put it back in the deck. After drawing first card from the deck, it's not returned to the deck. Okay, that's what it means. Fine. Now, what's event A? Our situation is where event A, we're going to call event A, picking a king. King. Event B is picking a jack. All right. So here is our formula. The probability of A and B is equal to the probability of A times the probability that B given that A has occurred. So the probability of A and B happening, right? What's the chances of what is the probability? The question is, The question is, what is the probability of picking a king and a jack? So here's our formula. Here's the question: the probability of A and B. That would be A is picking a king, and B is picking a jack. So A and B. So it's going to be the probability of A. What is the probability? Let's go to scrap paper, and let's figure out what is the probability of A. The probability of A is 4 out of 52 of picking a king. So over here, this is going to, probability of A is going to be 4 out of 52 times, what's the probability of B given that A has occurred? How many cards are left? You do not, you're drawn from a deck, and without replacement, you don't return it. You don't, after drawing a first card from the deck, it's not returned to the deck. So what is the denominator? The denominator is 51 because 1 is gone. One of the cards is now gone. So there's only 51 left. So what are the chances of getting a jack after you've gotten a king? Well, there's 4 chances out of 50 those 51 cards left of getting a jack. And so therefore it's 4 over 52 times 4 over 51, and you'll have to use your calculator to get the answer right over here, but this is the answer. This multiplication will lead you to the answer. Okay, so that explains, we've used up most of the paper. I have a little left, but I don't really have enough. So with this, we've explained the probability of dependent events. So we're going to go on to the next piece of 10.8 in the next video. So let's stop here.